In lesson 4.6, we're going to learn how to graph y equals the tangent of x. So once again, I can set up an xy table and pick values for x and plug them in, and using the unit circle, find the values of y, which is the tangent of x. So remember that the tangent of x, there are two ways to think about it. We can think about it as the y coordinate divided by the x coordinate, or you can think about it as sine divided by cosine. So if I want the tangent of 0 on the unit circle, so that means a turn of 0 radians, I want to take the y coordinate divided by the x coordinate. So 0 divided by 1 is 0. So the tangent of 0 is 0. Pi over 4. Pi over 4 lands me right here. And I don't have a coordinate listed here. That's a 45-degree turn. So I'm going to use my 45, 45, 90 triangle. The tangent of 45 degrees, or pi over 4, is the opposite over the adjacent. So that is 1. So the tangent at pi over 4 is 1. Then pi over 2. So pi over 2 is the same as a 90-degree turn. It's right here. Y divided by x would be undefined. Now, if you remember the sine and cosine graphs, I started with 0 and I skipped pi over 4 and I went to pi over 2. But if we were to do that with the tangent, we would have 0 and then we would have undefined, and we wouldn't really know what else is in between. So that's why I'm using smaller variations between my turns. So this is 1 pi over 4. This is 2 pi over 4, which reduces to pi over 2. 3 pi over 4, 4 pi over 4, which reduces to pi, and 5 pi over 4. So 3 pi over 4. Go back to the unit circle. Here's 1 pi over 4, 2 pi over 4, 3 pi over 4. I'm still going to use the reference angle of 45 degrees. So it's still going to give me opposite over adjacent is 1, but because I'm in the second quadrant, the tangent is going to be a -1, because in the second quadrant, the x coordinate is negative and the y coordinate is positive. So if you're thinking of tangent as y divided by x, it's a positive divided by a negative, which is a -1. Then the tangent of pi. Pi is a 180-degree turn. Y divided by x is 0. And then 5 pi over 4. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So once again, this reference angle here is pi over 4, or 45 degrees. So we're still going to have 1, but we have to decide if it's positive or negative. And in this quadrant, the x coordinate is negative, and then because you go down, the y coordinate is also negative. And a negative divided by a negative is a positive. So it's going to be +1. So we have 0, 1, undefined, -1. 0, 1, and then you can make a prediction. It's going to follow the same pattern, undefined, -1, if I were to keep going. So let's start to graph this. When x is 0, y is 0. We have to put a value for 1, and we have to put a value for -1. So pi over 4 is at 1. Pi over 2 is undefined, so that's going to give me an asymptote. So I draw in my dashed lines for a vertical asymptote. 3 pi over 4 is going to be -1. Pi I found to be 0. 5 pi over 4 I found to be 1. So in order to get a good idea of what this is doing, we probably want to keep going. Let's go to 6 pi over 4, which is 3 pi over 2. Go to the graph. We want the y-coordinate divided by the x-coordinate. That's going to be undefined, so that's going to give us another vertical asymptote. So what this is going to look like is something like this. And it's going to go up, and it's going to get close to the vertical asymptote, but never touch it. And here, we're going to want to find the other vertical asymptote over here. So if we go negative pi over 4, that would be a clockwise turn to here. It's using the same reference angle, pi over 4 or 45 degrees. So it's going to be either positive or -1. In this quadrant, the x-coordinate is always positive, but the y-coordinate is negative. And a negative divided by a positive is a negative. So it's going to be -1. So when I'm at negative pi over 4, I'll be at -1. And then I want to go negative pi over 2. So that's going to be a clockwise turn to here. Y over x is undefined. So that's going to give me an asymptote, a vertical asymptote right here at negative pi over 2. And so once again, it's the same shape. It's going to go up, get really close to the asymptotes, but never touch them. Okay, so here we have two periods of the tangent function.